For this demonstration, I'm going to use a high-end disc jockey DJ style DMX control board. Overall simple in design, it's highly portable because its simple 2-line LED display is built in, and this board has a joystick which can be fun with moving fixtures. This light board has only one DMX-512 output and uses the less expensive 3-pin XLR connector. That also means we'll have to connect all of our lights in one continuous chain. As for fixtures, let's start with some relatively simple light-emitting diode LED PARs. We need to start by plugging the units in to both power. These units use standard American 120 volt AC with Edison connectors, and to our light board via a 3-pin DMX cable. In order to control both these units, we'll need to daisy chain them by connecting one to our light board and then the second unit to the first unit. To keep our signal clean, we'll add a terminator to the second fixture. These PAR 38s have a few different modes that are available, including sound activated and slave options. But we're more concerned with controlling them with DMX, so we need to give them a DMX address. I'm going to set them to address 25. I'll explain why I chose that number a little later. For the moment, so that I can control both these units at the same time, I'm going to set them both to address 25. Before we can use these lights, we need to load their fixture profile into our control board. Many light boards have a different procedure for handling the same information. On this one, we're going to choose fixture and then unit 3. Now, this board doesn't have a profile for these exact PAR 38s, but its generic PAR 36 and PAR 64 profile will serve us just fine. We could also use the generic 32 DMX channels profile, but that would use up 32 channels when these units only need 3 for our purposes. Some fixtures use 32 DMX channels. This board breaks those into groups of 8, which can be controlled at any one time. In this case, we have control over 3 primary colors, red, green, and blue, in that order, from 0 to full intensity. Now remember that DMX has a range of 255, so full in this case is 255, not 100. Programming fixtures via DMX takes a little more planning and effort than standard lighting units and dimmers. With a standard PAR can, we'd only have one color frame in the unit, but we'd only have to send one channel's worth of information, intensity. In this case, we have to set 3 channels, but we can choose our colors on the fly. For the sake of video magic, I've pre-recorded 2 presets, 9 being red, and 10 being cyan. Now perhaps we don't want both fixtures to be controlled by the same channels. While this control can be useful for a full stage wash, sometimes the designer wants more control than that. In this case, we can simply change the address of one of the PARs. Let's make one of them address 26. Now, when we set a level for channel 1, only red from PAR 1 reacts, as expected. However, when we bring up channel 2, we get odder results. And if we jump to one of our presets, again, we get inconsistent results. The reason for this is that while par 1 is set to address 25, it actually makes use of 3 channels. So DMX address 25, 26, and 27 are controlling par 1. By setting par 2 to address 26, it also follows information from 26, 27, and 28, but in the same color order, so we get unintended results. To control units discretely, we must leave DMX channels 25 through 27 free. So let's set par 2 to address 28. Now we have full independent control over each fixture. Now realize that the presets we recorded only affect par 1 because channel 28 through 31 were at 0 when we recorded these looks. Let's take a look at some even smarter intelligent fixtures. Moving fixtures fall into 2 general categories: moving heads and moving mirrors. There are, of course, advantages and disadvantages to each. Moving mirrors tend to be less expensive overall, take up less room, and can be quieter. Their chief disadvantages tend to be that they have less range of motion and often have less features. This is an LED scanner which uses 8 channels. Not all scanners are created equally, of course. This one was really designed to be used in clubs by DJs. But it does offer us controls for pan, tilt, colors, gobo, strobe, shutter, dimmer intensity, 12 preset movement washes, and a speed control for those movements. The fixture connects the same way, with the DMX input, which will daisy chain from the pars. And we'll address it at DMX 17. Because it uses 8 channels, it actually uses channels 17 through 24, which is why we set our first par to address 25. Again, we have to load a fixture profile into our board. So I'm going to select fixture 2, and I've set it for the AccuScan 250, which is this particular unit. Now this fixture uses a color wheel, which is 8 colors plus white. These colors are created by glass gels, which are not changeable, so we cannot mix custom colors. Colors are channel 3. It does have a rainbow feature. Will continually rotate through the individual colors and then back again. And we can set a speed of that rotation. This fixture also has 8 gobos and open. It also offers a shake feature, which moves the gobo as if it were in an earthquake. It can also rotate through the gobos. It offers strobe shutter effects, but these are not like Lego shutters. We cannot reshape the light to a square or a doorway. It's really used for a strobe effect. Its dimmer actually does dim the LED, so it's quite smooth. And its movement patterns can be fun for cast parties. Units with a higher intelligence. Moving head fixtures are heavier than mirror-based scanners. They also tend to be noisier and more expensive. On the plus side, however, they usually have a wider range of movement they can cover and typically have more options available to them. This one's not an exception. It uses 16 channels to control the various traits. We're going to go to bank 2 so that we can access 11 and open its shutters. And then 12 so we can take the light up. Now I'll switch to bank 1, and we have control over pan movement, fine pan movement for small moves, tilt movement, fine tilt movement, use our joystick. We can control it that way as well as using the channels. A color wheel. Again, with its continual rainbow, which we can affect the speed. A rotating gobo wheel, a fixed gobo wheel. Now you might notice that it's a little out of focus. With the scanner, we would have to manually focus. So I switched to bank 10 so I could affect the focus. Now I'll switch back to the first bank so we can look at those fixed gobos. And it also offers a shake effect for each of the fixed gobos. Now notice that at this moment, the fixed gobos are focused. But the possibly moving gobos are not. So we need to choose either which gobo is in full focus or if we want both to be out of focus. This unit also offers a prism control. which either moves or stays fixed. Again, we have strobe and shutter functions. We can control the speed. An iris. Let's remove the gobos so we can see that better. A frost filter, and effects so that it can automatically go from sharp to soft or soft to sharp and faster and slower. Or we can just set it at a particular space and leave it. Obligatory cast party auto programs. This unit can pan rotate up to 630 degrees and tilt up to 265 degrees. It has a fixed color wheel with 8 colors, including a UV filter plus white. It also offers a rainbow effect, which is continual, so it can scroll forever in the same direction. Our color scanner wheel had to bounce back and forth. It has 7 rotatable gobos and 7 fixed gobos, all of which can be changed. And by combining gobos, we can create a wide array of wonderful effects. Here I've made a water effect. And I've pre-made a fire effect. Its shutter, too, is not like a Leica. It's primarily used for a strobe effect. And its dimmer is mechanical. In this case, it's similar to the closing of Venetian blinds, a procedure which is not as smooth or as pretty as actually dimming the lamp. But there is no color shift, and the lamp doesn't need to warm up to full intensity. It has an iris, which doesn't close all the way, and a frost filter. And control for its pre-programmed effects. I have this unit addressed to channel 1, and it takes 16 to control. That's the reason why the other units start at 17. Because all of our control channels total less than 512, we can use all of our fixtures at the same time. Lighting fixtures are not the only technology that use DMX. Many types of effects can as well, such as effects wheels, which rotate a projection wheel in front of a lighting fixture to create moving effects, color scrollers, which basically sit in the gel frame of a standard lighting unit, then use DMX to tell them which color to scroll to. There are remote irises and shutters, which can remotely reshape the light from a standard or intelligent Lico. There are even remote control arms that can make a traditional fixture move like an intelligent fixture. Another lighting challenge that has crept into the theater in recent years has been controlling data projectors. While data projectors as a whole are outside the scope of this CD, lighting designers are often given the task of controlling and supplying power to these fixtures, even if the set designer or a specific projection designer is responsible for the images that are projected. A specific challenge with data projectors is that when they fade to black, they're actually trying to project black, so it's not a true blackout. This fade can leave a distracting glow on stage when a blackout is called for, and can leave the audience seeing moving silhouettes caused by light spillage out of these darkened units. City Theatrical, a manufacturer of many DMX-controlled lighting effects, has created a projector dowser that rotates a metal flag in front of a projector, eliminating the light spillage typically left behind a projected black. In this particular unit, a DMX signal runs into a power supply, which then sends out a 4-pin DMX cable signal, 2 pins for the signal and 2 pins for powering the unit. The fixture can then be hung on a sidearm in front of the offending data projector, or attached beside or on the fixture itself in some cases. The metal flag can be attached so that the channel set to 0 is either the flag open or closed, with the channel at full rotating the flag into its other position. You can see that DMX can operate a large array of fixtures in the lighting designer's toolbox.